Thanks for taking the time and sitting in on our presentation. Today what I'm going to be talking about is Workload Manager, and I've used Workload Manager for many, many years, typically just in passive mode because it gives some very interesting reports and provides you with some details on what you can do with the system. If you have a look at this front slide, and I also have this on the back slide, I have the link here for the presentation, and you can actually download it from here. And I've done it in one-up PDF format. Also, any of the links in there should be clickable. What we're going to talk about today is a very quick introduction to Workload Manager. We'll talk a little bit about setting up Workload Manager. We'll look at some of the commands. We'll look at WLM itself and Nmon and how they're integrated. And then I'm going to log into our system and do a bit of a live demo, and then we'll open up for questions. So let's start with the introduction. Workload Manager has been around since AIX 4.3.3. A lot of people don't realize that. However, up until about 5.1, it was really pretty useless. In 5.2, they added some stuff to it, and now, when we're at version 6 and 7, we've really got some meat. And in fact, Workload Manager is pretty fundamental to how WPARs work. If you implement WPARs, it will implement Workload Manager for them. The idea behind Workload Manager is that it's going to give you granular control of your system CPU, your memory, and your disk I/O. And it does that by using classes and shares and tiers and so on, and we're going to talk about what those are and how they work. Unfortunately, the documentation on it has not been updated pretty much since 2001, so there's a very good red book out for AIX 5L, but it was really written at around 5.1 or 5.2. One of the reasons why a lot of people, I think, don't use Workload Manager because they think it's out of date, whereas in fact it is constantly being updated. So what Workload Manager does is it looks at the threads in the system and it assigns them to classes based on rules that you write. You can also assign things manually. As with our weights on the HMC, it uses percentages and shares. It doesn't really do absolutes. So what you'll find is it'll assign minimum and maximum percentages for resources. And there's a number of different ways you can identify and classify things. Primarily you're going to be identifying and classifying processes, and you do it by owner or group, the full path and name, the process type, or by application tags. And most of the time you'll do it by owner or group or the full path and name for the application. You can assign classes to tiers. So for instance, if you want batch to run slower than everything else, or basically to have less priority, you can put it in a tier so that it does not get looked at until everything else is run. And as I mentioned, you can run it in passive or active modes. And typically what people will do is they'll write their rules. They will run Workload Manager in passive mode for a significant amount of time, and then they will figure out from that whether they've got their rules correct, and if they have got their rules correct, then they'll switch to active if they want to actually have it managed. Because it's got very, very low overhead, I tend to implement it and just run it in passive mode so that I can monitor what's going on in the system better. And of course, in order to be able to function, it has to be integrated with the kernel. So it's actually got some integration with the scheduler, with the virtual memory manager, and with the disk device drivers. So it manages CPU utilization, memory, and disk I/O bandwidth. And the way it does that is it looks at the threads, it categorizes them into a class, and then it sums up the CPU cycles consumed by every thread in the class, and then based on that it looks at the limits and the shares that you've assigned to that class and distributes out the CPU amongst them. For physical memory, it looks at the sum of the memory pages, so it's a memory page count, not a byte count. And then for the disk I/O bandwidth, it looks at bandwidth in terms of 512 bytes per second, 512 byte blocks per second of all the I/O started. So, as you can see, it looks at the three things quite differently. One of the first things that happens is that you have to come up with a classification scheme. That's going to consist of tiers, classes, subclasses, and limits and shares. So, as an example, by default, everything is in tier 0, and that's the most favored tier. You can have tiers going from 0 through 9, with 9 being the least favored. Typically, people will have two tiers. They'll have tier 0, which is the stuff they just want to run normally, and they may have a tier 1 for batch, but you have the option of having up to 10 of them. Classes are where you categorize all of your processes to be separated out. So as an example, you might take all of your monitoring software and create a class called Monit. You might take your SSH and create a class called SSH. You might want to monitor everything that I do, so you might create a class that the user ID, Jackie, anything that she does drops into it. You have the ability to do that. You could also have, which I'm going to show you, an SSH class where everything for SSH is reported to it, but it now has a subclass for a specific user ID, so that that's reported out separately. And then if we look at limits, you have a minimum, a soft maximum, and a hard maximum. And we'll go into those in a little bit more detail. Just keep in mind that limits take precedence over shares. So how does it work? So there's this thing called a Uniform Resource Access Priority, or a URAP. Just like with all other priorities, the lower the number, the higher the priority. What Workload Manager does is it calculates percent usage for every resource once a second. It compares the average against the targets and limits, and it comes up with a priority number. That priority number is used to determine whether it's going to favour or restrict the resource based on how much of its resources it's using. It's going to be a positive number. The nice default is 60, and so what it's going to do is it's going to range that number from 60 to 255. And just keep in mind that 255, which is something we would normally never send a process to, is used by Workload Manager to do what we used to call the mainframe sending something to the black hole. Basically, it freezes the process. What will happen then is that when it's not using all of its resources, it will then drop it back to a better priority. And it calculates it for every class, looking at the superclass and subclass tiers. If you define constraints, the constraints are given precedence in the order of any hard limits. So if you put a hard limit of 30% CPU, you should be able to have that be implemented. It then does tiers, soft limits, and then shares. The other thing is that Workload Manager will reserve a priority range for every superclass and then a sub-range for each subclass. And I'm going to get into explaining the difference between superclasses and subclasses. So let's have a look at how it works. In terms of CPU, it actually gathers the utilization threads for each class 10 times a second in 5.3 and higher. Now, if you remember on the previous slide, I'd said it details the utilization every second. That was up until 5.3. I think it's 5.3 TL5. This all changed. Hopefully you are all at higher than that. It's going to come up with a time-delayed average. This is important to remember because if you're comparing output from SAR and the Workload Manager, you need to remember that Workload Manager uses time-delayed averages. So we call that a decade number. SAR and VMstat and things like that use raw numbers. So they're using it absolutely as it is at the time. So you may see a couple of little differences because if something changes dramatically, it'll show up immediately in SAR, but in Workload Manager it might take a couple of seconds because it uses that decade average. So it's going to compare that average against all the tier values and targets and limits and so on, and then it will come up with a URAP that will either favour or penalise the threads. In terms of memory, it also monitors that 10 times a second, and it enforces percentage-based memory limits. So I can say that I get a minimum of 5% memory, a soft maximum of 60, and a hard maximum of 70, and when I get to 70% memory, the least recently used daemon is going to start stealing pages from the class. And keep in mind that when you set that percentage, let's say you set your hard limit to 30%, if there's still thousands and thousands of pages free, when you hit your 30%, you will start to steal pages from that class. So you have to be a little careful when you're starting to put in hard limits. That's why it's a good idea to run this in passive mode for a while first. Also with devices, you'll find that if the class needs to be restricted, then what will happen is Workload Manager will simply delay that at the IOs. Typically what I see people do is, if they're running this in active mode, they may put some hard limits on CPU and memory. They very rarely do it on devices. And if they do it on CPU and memory, they're very conservative, and then you work your way down to what you really want those numbers to be. Alright, so I've mentioned passive mode and active mode. So when you first bring Workload Manager up, you use the WLM control command, or you can do it through SMIT. What this command here is doing is it's saying, bring up the configuration called prod95 and run it in passive mode. And by the way, if you run WLM control with nothing, what it does is whatever you're running currently with WLM control, it will turn it into active mode. And you can see here on the next slide that when you run WLM control and you don't have the -P, it will come up inactive. If you run it with the -Q flag, it tells you what mode it's running in. So anytime you start a new configuration, what you want to do is make sure that you run the WLM control -Q afterwards to check and see if you've accidentally brought it up in active mode, because I can tell you I've accidentally done it several times. Alright, in terms of implementation, the first thing you want to do is design a classification criteria. And what I tell people is, first of all, come up with your primary or superclasses, as they call them, and don't get complicated, make it pretty simple. Then you're going to have to create a directory, this prod 95 one is what I'm calling mine, and then you copy the templates into there. Now you can also copy everything out of etc.wlm/standard, because that's some of the defaults. But basically, you're going to go into that directory then, and you're going to edit the classes, the limits, the shares and rules, and you're going to make them match the criteria that you chose. Then you're going to bring it up in passive mode. Then you'll go into, for instance, if you're doing Nmon recording, you want to go in and there's a new flag that you put on it, a -W. That will actually get you some new tabs, and I'm going to show you the output from some of those. Then you're going to monitor it, and you have a couple of options at that point. Once you're sure that you've got all your rules right and that you've got the granularity that you need, then you can run in passive mode forever, which is what I tend to do, or you can put it into active mode so that it's actively controlling things. The good news is it is dynamic to change to passive mode. So if you find you put it in active mode and suddenly it's controlling things in a way you didn't expect, you can just do a WLM control -P and immediately switch it to passive mode so that it's just monitoring again. So what are the files that you need? At a minimum, you need a classes file, a limits file, a rules file, and a shares file. So the classes file is going to define what they call a superclass. Then you'll see the limits that you set for each one. I'm going to take you through these files, and then at the end we'll do a demo and we'll go and have a look at how I've set up my test system. We'll define some rules so that we know what to put in each class, and then we'll define our share limits. I don't usually bother with share limits. I usually just use limits. You may have a description file, and you may have a directory that then has the same files in it for subclasses. You'll also probably end up having to create a .loc file.